One of my biggest goals this year is passing SOA Exam PA. And instead of studying alone, I decided to bring you guys with me. In this series, we will dive into reviewing concepts, explaining things in simple terms, and most importantly, holding each other accountable. So grab your notes, grab your coffee, and let's dive into the first 10 flashcards from Chapter 1. Welcome to Glowing Together. Explain the objectives of descriptive, predictive, and prescriptive modeling. One of the big things for descriptive is past. So I'm going to start with that. So descriptive modeling is where you're looking at the data. Log it. Descriptive means we're describing things from the past. So we're looking at past data, trying to understand the patterns and the relationships between the target variable and the predictors. Predictive modeling is going to be where we are trying to look at and predict future events. Prescriptive modeling is going to be when we are taking simulation, when we're taking simulation and optimization, and we are we're doing testing, like we're trying to find the best outcome. Okay. Descriptive focuses on what happened in the past and aims to describe or explain the observed patterns by identifying the relationships between different variables in the data. Predictive modeling focuses on what will happen in the future and is concerned about making accurate predictions. Prescriptive modeling uses a combination of optimization and simulation to quantify the impacts of different prescribed actions in different scenarios. So I was pretty close. I need to get a little bit more detailed about the definition that I'm producing, when I'm saying it out loud, but I do think that it's good that I hit a lot of those keywords. So it focuses on what happened in the past. It's observing patterns and identifying relationships. So past patterns, relationships between variables in the data. So I know I said between the target variable and the predictors, but I think that part was incorrect. So we would actually need to focus more. So instead of that, we would focus more on just the different variables in the data. And the prescriptive, I've made sure to remember the optimization and simulation. Why can I not say that word? Another one, quantify. So we're trying to quantify the impacts of different prescribed actions. I think a really good use case for descriptive analysis would be in my day-to-day work as a senior actuarial analyst. We oftentimes have to take large amounts of data and look at them and basically find the patterns and find what the drivers are to the data that we're seeing. So I work for health insurance. If we're going in and we're looking at our financial data and we're working in the, let's say the ACA market, we would see that members who have silver plans are having very high utilization or very high unit cost trends in the data. So we would go into that data and try to find what those different drivers are. And this is looking at something that has already happened and trying to find patterns and relationships between the different variables. So do they have certain HCC codes being put in? Do they live in a certain area code? Or is it the older population that's driving the high utilization? As far as predictive analytics, I would say this more so aligns with when you're trying to price. So I'm currently on a pricing team. When you're pricing for insurance products, you have to use past data, right? Descriptive analytics to understand the relationships, but then you use that data to try to predict what will happen in the future. So that's called experience data. We use that along with things like trend and area factors and all these other things to help us predict where the market will be so that we can price accordingly. Prescriptive would be once we are in the midst of pricing, we are going to test out different scenarios to make sure that our pricing is robust. We don't want, some crazy outlier or life event to happen that we haven't accounted for. So we do immense testing to make sure that in all scenarios, we will be able to pay our claims. Compare and contrast nominal and ordinal categorical variables. Nominal and ordinal categorical variables are similar in the sense that they both have levels or classes, i.e. categories. So they are made up and comprised of categories. And then they're different because nominal categories have no prescribed order to them that matter, where ordinal categorical variables have a prescribed order, such as first place, second place, third place. Those things mean something. Rather than if I told you, what's a good example for nominal, where the order does not really mean anything? Oh, like categories like orange, blue, green. That has no real meaning to you. Or like no hierarchy of order. They said both nominal and ordinal categorical variables take values in predefined levels or classes. And in contrast, the levels in a nominal categorical variable have no numeric order. There is no unambiguous way to order the levels. On the other hand, the levels of an ordinal categorical variable do have a natural order. For example, if health status is a categorical variable with levels poor, moderate, good, and excellent, then there is a definite way to order the levels. I could have been a little bit more precise with the contrast to really include the word numeric order, no numeric order, not, oh, like doesn't have importance, or doesn't have, yeah, I think I should focus on numeric. The levels in a nominal categorical variable have no numeric order. Explaining two differences between supervised and unsupervised learning. I think the easiest one is always going to be that supervised learning has a target variable and unsupervised learning does not. So something that I've kind of noticed when I'm doing these flashcards is Exam PA wants you to like literally, like when it comes to these definitions, you can tell them exactly what it does. And I know that sounds simple, but I feel like with all these exams that we've had, this one's a little bit different. You telling them exactly what it does is partially what they're looking for. So don't overthink it, you know? And I think I was about to overthink it because I kind of remember this flashcard. We'll see when we get to the back. But I think that the second difference is going to be that the supervised learning wants to find the relationship between the target variable and the predictors. Whereas the unsupervised learning is coming up with patterns and relationships of the variables. So kind of back to that more descriptive analytics area, kind of, I feel like. I could be wrong. In the comment section, let me know if I'm wrong about that, but that's kind of what it seemed like to me. In supervised learning, there is a target variable guiding our analysis. So it's supervising our analysis. In unsupervised learning, there's no target variable specified. So we got that first one. In supervised learning, we seek to understand the relationship between the target variable and the predictors. Okay, yeah. And or make accurate predictions about the target variable. So I missed that part, but I did get the first part. So we want to make accurate predictions about the target variable. So we can't forget that part, the supervised learning. Okay. In unsupervised learning, we are interested in extracting relationships and structures between variables and or between observations in the data. So I think keywords here are going to be extracting relationships and structures between variables and or between observations in the data. Let's ask chat, what is the difference between a variable and an observation? We should ask chat. Calling in chat. All right, guys, chat has answered and we have a response. A variable is something you measure or record about each individual. So age, salary, whether they purchased insurance. Another way to think about this would be a variable is equal to a feature, a variable is equal to a predictor, or a variable is equal to columns. So I think this is one of the biggest things that helped me. I only learned this recently. I've been taking exams for years, but a variable is a column, observation is a row. So helpful. Variable, column, observation, row. Variable, column, observation, row. Variable, column, observation, row. Variable, observation. Just like that. Variable, observation. An observation is one complete set of measurements for a single individual. So we need to think of the variable as measurements. Measurements we are taking about someone, something. Those are the different variables, and those variables can change. You don't know what they can be or what they will be. They may change. So age can change, purchase insurance can change, salary can change, okay? But what cannot change is the person that you were looking at all that data for. And how many people you have that you're looking at that data for are all the different observations that you're making. You're welcome. Imagine that you're in a classroom. Each student that you see is going to be an observation. You're observing them. You're observing them. Each student, they're all there. Each thing that you know about the student is going to be your variables, the things that could possibly be different about each one to make them who they are, that one observation. Explain the main difference between regression and classification problems. You're going to have a numeric target variable. Classification, you're going to have a categorical target that you're going for. Is that a main difference? I think that's the main difference. Let's see what the flashcards say. Problems in which the target variable is numeric are referred to as regression problems. In contrast, problems in which the target variable is categorical are referred to as classification problems. You see, I almost overthought myself there, but that was right. So just keep it simple. Don't overthink. 3 characteristics of predictive modeling problems. Okay, guys, so I actually took exam PA in April, but I didn't actually receive my study hours at the time. So I was just in there kind of taking notes. And I actually saw this question on the exam. So I would pay close attention to this and make sure that you can remember at least 3 of the 5. How I've been trying to remember this is that there is like a natural order to these categories. For one is going to be issue. There needs to be a business issue that can be solved. Well, there needs to be a business issue and that you have questions about. The second characteristic is going to be questions. Does this business problem have questions that you can easily answer? Okay. So issue, question. Then once you have a question, so now you have all these questions. Now we're like, so how do we answer our questions? We answer our questions using what? Data. Okay, so data quality, that's number 3. We need to have good and useful data. Simple. Number 4, once we have good and useful data, what are we going to do from there? Let's see. Oh, impact. We want to make sure, before we do anything, right? We want to make sure that this is going to have an impact, meaning it's going to maybe help you understand something more or drive decisions for the business. So impact. And I think it was actually 6. I said 5 earlier. 6 characteristics. 5 is going to be, and I don't remember the characteristics exact name, but I know the description. We need to make sure that this is going to be the best option out of all options. Using predictive analytics is going to be the most efficient way, the best way to get answers to our questions. And number 6, last but not least, is update. So you want to be able to make sure that you can easily update this model and keep it basically going for years to come so they can use it in the business. Now let's read what the ACTEX manual wants to say. Issue is number 1. There's a clearly identified and defined business issue that needs to be addressed. Number 2, questions. The issue can be addressed with a few well-defined questions. Number 3, data. Good and useful data is available for answering the questions above. Impact. The predictions will likely drive actions or increase understanding. Better solution. Predictive analytics likely produces a solution better than any existing approach. And update. We can continue to monitor and update the models when new data becomes available. If I was going to point out keywords, I would say for issue, I need to maybe use the words clearly identified and defined business issue. I'm going to remember those. Questions. Well-defined questions. So the issue can be addressed with well-defined questions. Data. I already had that one. Good and useful data. I had that one locked in. Impact. Increasing understanding and driving action. I had that. Better solution. That's the word I missed. Predictive analytics likely produces a solution better than any existing approach. We want to have the best solution to our questions. Update. We can continue to monitor. Update. I need to remember monitor and update the models. Monitor and update the models. Monitor and update the models. When new data becomes available. When we get something new. And if we want it to be, essentially we want it to be robust. I've been holding on to that word. Look that word up. Explain 2 desirable characteristics of a key performance indicator. Once again, this is another one where they could trip you up and it's literally simple. And they just want you to tell them exactly what it is. Desirable characteristics of a KPI. 1, it needs to be measurable. So, as for a key performance indicator, you want to be able to quantify and measure your performance. So it has to be measurable. And 2, it needs to be relevant. We want to have relevant indicators that align with our business and the needs and questions of the business. So I think I can actually tighten that response up a little bit. So let's see what the KPI should align with the overall business objective and the interests of your client as closely as possible. So I need to remember business objective and interests of client. Relevance, business objective, interests of client. Measurability, they should be easily measurable from data and provide an objective. So we want no bias, quantitative basis to measure the success of the project, i.e., what key numbers will change in the future as a result of your predictive analytic work. Explain how stratified sampling works and why it contributes to a more representative sample than random sampling. How stratified sampling works is non-randomly, you are going to split the data into groups, either with respect to the target variable or with respect to your predictors. When you split them into those groups, you are then going to random sample from each group until you have a new population of data. This contributes to a more representative sample than random sampling because you're ensuring that you have data points from each specific category, making it a more well-rounded sample. The idea of stratified sampling is to divide the underlying population into a number of non-overlapping strata. So I need to, instead of saying non-random groups, I need to say dividing the population into just a number of non-overlapping strata. So I think that's important for me to put that in there because if you leave that out, there is room to interpret, if you were telling this to a random person, that maybe the groups overlap, but they don't. So a number of non-overlapping strata, either with respect to the target or with respect to the predictors, got that part, non-randomly. Okay, so I can keep that in there. I just need to also add this non-overlapping strata. And then you randomly sample a set number of observations from each stratum to get a more representative sample. This produces a more representative sample because it ensures that observations from each stratum are represented. Explain 3 data quality issues one should examine in practice. So, lock in brain. Okay, so something that we are always hear as an actuarial analyst when you're looking at data is to check for reasonability. You do not want to just have like random, like you don't want to just trust that the data is correct. If something is off, this could affect millions of dollars worth of business. So we're always checking throughout our work for reasonability, and that is one of our data quality issues that I know is going to be on this flashcard. So reasonability, we want to make sure that our data is going to make sense. Like we want to make sure that it makes sense. I know I'm going to have to tighten up this response, but it seems as simple as that to me. Okay, number 2, consistency. We want to also make sure that, yeah, the data is reasonable, but that we're being consistent with the way that we input data, like the unit that the data is in. We can't have something in like a base unit and then something else is like squared and we're comparing the two. That wouldn't make sense. Third data quality issue is going to be documentation. We want to always make sure that we're documenting where our data is coming from, what the data is, so that the next person who may have to take over your work or has to start working with that data has some baseline information that they can work with, so they are, analyzing appropriately, understanding correctly, and we are being efficient as a business. So reasonableness. So not reasonability, but I think they'll probably take it. Reasonableness. So for a data set to be useful, the data should at minimum be reasonable. You see how that was kind of like redundant? No, like, because to me it just seemed as simple as make sure it's reasonable. So I guess that's okay to have in there. Be checked by exploratory data analysis, which we have not gone over yet. Number 2 is consistency. So that was right. We also need to ensure that the records in the data are input consistently, meaning that the same basis and rules have been applied to all values so that they can be directly compared with one another. So I did mention the comparison. I did mention these things. I just think I need to tighten it. So let's see what we can focus on. So we're going to ensure that the records to the data are input consistently. So the records need to be put in consistently. having the same basis and rules that we can compare. Input consistently, same basis and rules, so that we can directly compare it with one another. And third is sufficient documentation. A good data set should also be sufficiently documented so that other users can easily gain an accurate understanding of miscellaneous aspects of the data. And what a proxy variable is and why it may be problematic. So when I was first going over these flashcards and trying to remember this, like once again, keep it simple. I literally sat here before I knew what it was supposed to be. I sat here and I was like, proxy. What does that mean? Okay, proxy is like close, similar to a similar variable. Like that's literally kind of how I went through that, and that was the right answer at the time. So let's see if I can verbalize it here. The variable is a variable that is similar to, close to another variable, and this can be problematic, especially if you're trying to exclude certain information from your model. So to edit that a little bit, I would say that the proxy variable could give away information about something you're trying to predict. So if I am trying to predict the salary somebody makes, a proxy variable that could go in there is, let's say, if they went to medical school, right? Like that's obviously kind of gonna, I think that's a good example. I'm not sure about my example, but I'm pretty sure about my definition. Just stick with like the med school comment, because I feel like that gives you like an unfair push to like know what the salary would be. Like you're not gonna guess, oh, you went to med school, now you make $50,000. Like, let's see. Proxy variables are variables that are closely related to, hence serve as a proxy of, other variables. They're closely related to other variables. So proxy variables may be problematic if they serve as proxies for prohibited variables. For example, occupation, possibly a proxy of gender. So if I was trying to predict gender and I included occupation in there, for example, what if my occupation is like a construction worker? It's kind of too close to the variable that we're trying to predict, because most of the time a construction worker would be male. Okay, and another one that they gave is geographical location, possibly a proxy of age and income. So I feel like my example works. You guys let me know in the comments. Do you think my example works? And if not, tell me how to fix it. Thank you. Last flashcard for today, in the problem with target leakage and predictive analytics. So this one I think is a good one to end on, since we just did proxy variable. Like in your head, if you obviously don't know exactly what it is, it's going to sound a little bit similar. So proxy variable is different than target leakage. Proxy variable, target leakage. Proxy variable, target leakage. Okay. So target leakage information. Oh, I got it. Tells you information about. Okay. Target leakage. You have a variable or a predictor, right? Predictor that would require information that we would not have at that time of trying to make a prediction. If I'm trying to predict the number of accidents somebody gets into in a year, if I make number of submitted auto claims my predictor to try to understand how many accidents an individual gets into in a year, that is going to require information that we technically wouldn't have at the time of modeling. So would we know, how many insurance claims you submitted over a year if we don't even know? You feel me? Okay, you feel me. Target leakage refers to the phenomenon whereby some predictors in a model have information about the target variable that will not be available when the model is applied in practice. If we mistakenly include these predictors in the model construction process, then our model will appear to perform extraordinarily well, deceptively, and unrealistically well, however. I think my answer was good, but I need to make sure that I add that if we mistakenly include these predictors in the model construction process when we're constructing the model, then our model will appear to perform extraordinarily well, deceptively, and unrealistically well. With the example I gave, you would almost have had a perfect prediction, right? If I know exactly how many claims you submitted in a year, I can accurately predict how many times you had an accident in that year as well. Prediction performance will be off, but also it doesn't logically make sense to include that predictor when you wouldn't even have that information in the real world. Be it for today. Thank you guys so much for following along to these first 10 flashcards. I will be posting a part 2 for the next 11 flashcards in chapter 1 coming soon. Make sure you guys like, comment, and subscribe, and let me know how you like the study session, if there's anything that you guys want me to include, if there's any questions you guys have that we can answer together, because I may not know all the answers, but I'm sure you guys also have great insights to add to this conversation. And you guys have examples that you guys want to throw out there that are real business like examples or things that you saw on past exams that you think would be helpful, please feel free to leave it in the comment section. We are all trying to get through these exams one exam at a time. It can take months, it can take years, but I think that with a community, we can continue to glow together. We're not always going to pass on the first try, but it's so important that we just continue to go and glow and grow together. So thank you, thank you, thank you. Make sure you guys tune in next time for part 2, where we're going to go through flashcards 11 through 21 to finish out chapter 1. And don't forget, if you're serious about ownership, start with education. And if you're serious about education, subscribe to Glowinn together.